This is day 2, pages 3, 4, 5. We're going to do skill and drill of sketching functions from a given description. We're going to sketch a graph first where it says we have a continuous function. Continuous function means we're going to draw a graph with no holes, jumps, or breaks. You should be able to draw the graph without picking up your pencil. So it says our continuous function is decreasing concave up from negative infinity up to 5, and then decreasing concave down from 5 to infinity. So it's decreasing the whole way through. So as I draw this graph, it should only be going down. First concave up, then concave down. So let's see. Concave up, decreasing, then concave down, decreasing. Put little arrows at the end, and this point right here where it changed concavity occurs at x equals 5, where we have an inflection point. Decreasing concave up, then decreasing concave down. Next, a continuous function. It has a local max at x equals 20, so it'll have a peak at x equals 20, and then it has an inflection point at x equals 25, and then it has a local min at x equals 30. So let's see, we're going to draw a graph that has a local max at x equals 20. So something like so, for example. There's a local max at 20. It says it has an inflection point at x equals 25. So we keep going a little bit, and then at x equals 25, my graph right now is concave down. I'm going to change it to concave up. And then it says it's going to have a local minimum at x equals 30. So a very low point in its region there. So here's an example. Max at 20, inflection point at 25, min at 30. Continuous function, it approaches y equals 0 on the right tail, so I better draw an x-axis here. And it approaches y equals 300 on the left tail. So let's see, let me just draw an xy axis. So here is y equals 0, the x-axis. Y equals 300, why don't I just draw a dashed line to indicate y equals 300, that's a height of 300. It says on the left it approaches y equals 300. So my graph on the left should approach that height. It says on the right it approaches the x-axis, y equals 0. And it doesn't describe what happens in the middle, but I could, for example, do something like this. All right, a continuous function, it has a domain x greater than 0. So it does not exist over here on the left side of the y-axis. Only exists on the right side of the y-axis, only for positive x's. It says it has a range of all real numbers, so the graph should exist from top to bottom everywhere. And it says the function is decreasing. So it only exists over here on the right side of the y-axis, and it's going down about something like this. So this graph is decreasing forever. It's getting closer and closer and closer to the y-axis here. Decreases everywhere. The domain is all the positive x's, and the range is all real numbers. For the given graph, answer each question. All right, so we have a graph here. I'll just notice it's got arrows on the left side, arrows on the right side, so it exists everywhere left to right. Seems to be approaching a height of 150 up here on the left side. Seems to be approaching a height of y equals 0 on the right side. All right, it asks first, local maximum points. It doesn't seem to have any peaks, so there does not seem to be any local maximums. Also doesn't seem to have any valley points, so there doesn't seem to be any local minimums. There does seem to be an inflection point. You notice over here, it is concave down. But certainly over here, it's concave up. So it's concave down on the left and concave up on the right. So certainly there is a point of inflection somewhere in between, and we're just going to estimate that point. So later in the course, using calculus, we'll be able to identify the exact inflection point. For now, we're just going to estimate it. Looks like it's maybe somewhere around here. So if this is x equals 0 here, and this is x equals -5 here, maybe, I don't know, I'd say maybe x equals -2 approximately. And let's see, the height of the function there is between 50 and 100. Let's just estimate about 70. And it's just an estimate again. We'll be able to identify exact inflection points later in the course. Next, the right tail behavior. So over here on the right side, it's approaching y equals 0. So y is approaching 0. What interval is the function increasing concave up? Well, never. This graph is decreasing everywhere. As you travel left to right, it's decreasing. So it's never increasing concave up. Where is the function increasing concave down? Again, it's never increasing. Next, it asks, where is the function decreasing concave up? Right, well, it is doing that. Decreasing concave up, it's right over here after that inflection point. Now, if we're saying the inflection point occurs at x equals -2, then from -2 onward, from x equals -2 up to infinity, the graph is decreasing concave up. So we would describe that as -2 is the low, comma, infinity is the high. So there it is in interval notation. What is the interval where it's decreasing concave down? So that's over here on the left side of the graph. So from -infinity up to that inflection point at -2. So the low is -infinity, the high is -2. So in interval notation, we write the low is -infinity, comma, the high is -2. That's where it's decreasing concave down. Okay, next, another example. For the given graph, answer each question. So we're going to identify max, min, inflection points, and intervals of behavior. First, I'm just looking at the graph here and identifying the main points of interest. Right here, it looks like we have a little local maximum. I'm going to just estimate that. Let's say it occurs at about x is 6, and I guess y maybe is about 100. This inflection point where it changes from concave down to concave up, looks like it's maybe x is about 12. Y, I'm going to say, is about -100. And here, this local minimum point, lowest point in its little region, I'm going to say it's about x is 17, y is maybe -300, I'll say. Again, these are just estimates. Later in the course, we're going to be able to identify those inflection points and max min points exactly using calculus. So for now, our estimates on these values, local maximum looks like it's at about 100. Local minimum looks like it's at about 17, -300. Inflection at about 12, -100. All right, right tail behavior. Over here on the right side, it looks like the function is diverging up to infinity. The y is approaching infinity, diverging. Interval where the function is increasing concave up. It's going up and it's concave up over here on this right tail from x equals 17 to infinity. So the interval where it's increasing concave up is from 17 up to infinity. Where is it increasing concave down? That's over here on the left side. It's going up, but it's concave down. So from -infinity on the left side up to 6 on the right side. So from -infinity up to 6. Give the interval where the function is decreasing concave up. Decreasing concave up. So from the inflection point over to 17. decreasing and it's concave up. So from x is 12 to x is 17. So from a low of 12 to a high of 17. And where is it decreasing concave down? That's that last interval right here. From x is 6 to x is 12. It's going down and it's concave down from 6 to 12.